This problem features two people pushing on a gate, and what we're trying to find is in what direction is the gate going to swing if they're both pushing as designated here. So really, what we're going to need to find in order to solve that question is what's the net moment that they are imparting on point C. And the information that we're given in this is the amount of force that each person is exerting. So they tell us that FA is 30 pounds and FB is 40 pounds. All right, so if we look at the diagram for this, we're going to have our point C over here. And then we're going to have the rest of the gate. So person B is pushing with that force FB of 40 pounds, and they're pushing on the gate 6 feet from C. And they tell us that this is a 60-degree angle. And then person A is pushing with 30 pounds, and that makes a 3, 4, 5 triangle. And they're pushing from at least point C 9 feet away. So what we want to find or calculate is what's the sum of the moments acting around point C. In this problem, we're not told it's an equilibrium, so it's not necessarily going to be 0. In fact, it's probably not going to be 0. So our convention is going to be that counterclockwise is positive. And we want a coordinate system over here. I'll use x, y, and z coming out of the board. In which case, if z comes out of the board, again, moments are counterclockwise positive around that z-axis. So we want to calculate what's the moment caused by the 40-pound force and what's the moment caused by the 30-pound force. So let's start with the 40-pound force. So again, what we can do, because it's off at that angle there, we can break it down into a vertical component and a horizontal component. So right away, we look at the horizontal component, and its line of action points directly at C, the point we're trying to take the moment around. So we know that the horizontal component is not going to add to the moment around C because its distance, perpendicular distance, is 0. However, the vertical component will cause a moment around point C. So this vertical component is going to be 40, and the vertical component is opposite the 60, so it's going to be sine 60. And its perpendicular distance to point C is going to be, again, made up of the distance from C that's perpendicular to the force, in which case we're given that 6 feet. And this is in pounds, so it's pounds times feet. And lastly, we want to determine, is this force going to be clockwise or counterclockwise around C? So holding down at C and pushing this way, the whole system would want to rotate counterclockwise, so this quantity is going to be positive. So the horizontal was 0, this is the vertical component. Same thing for the 30-pound load. We can break this down into a vertical component pointing down and a horizontal component pointing to the left. Once again, the horizontal component has its line of action pass through C, so it does not contribute to a moment around point C. But the vertical component will. So the vertical component is going to have a force value of 30 times 3/5. And the perpendicular distance from C to the vertical component, again, the vertical distance here, is going to be 6 plus 3, 9 feet. This is in pounds, and times 9 feet. We need to lastly determine its direction. Is it a positive or a negative moment? Holding down at C, rotating, pushing down at this end, the whole system would want to spin clockwise around C. So this is going to be a negative moment around point C. Again, horizontal was 0. So we've accounted for all the 4 components we've created. Only 2 of them were non-zero moment around C. So Again, we don't know it's in equilibrium, so it's not going to be equal to 0, but we can add all of these numbers together and get the net moment around point C. So we're going to get 208 minus 162, and this is going to be in pounds times feet. So in the end, we get positive 46 pound-feet as the net moment around C. So lastly, we want to interpret this. The question is asking, which way will the gate rotate, clockwise or counterclockwise? So the net moment is going to be positive. We've designated as positive is counterclockwise. So this means if there's a net positive moment around C, that the object will rotate counterclockwise around C. So therefore, we have counterclockwise rotation.